Problem number 26. Find the angle between these two vectors and classify the angle as like acute or obtuse. So this is going to be V is 1, 2, 3. W is 2, 1, 4. V dot W here is 1 times 2 is 2, plus 2 times 1 is 2, plus 3 times 4 is 12. So the dot product here is 16. Okay, what is we know that to get the angle between it, we need the dot product. So what's the formula here? Cosine of theta is equal to V dot W divided by the magnitude of V times the magnitude of W. We also need, I guess, the magnitudes here. So this is going to be the square root of 1 squared plus 2 squared plus 3 squared. So that's square root of 14. The magnitude of W is going to be 2 squared plus 1 squared plus 4 squared. And so this is square root of 21. So cosine theta is 16 divided by square root of 14 times square root of 21. And is cosine theta. And to finish this off, I said you could leave it as inverse cosine. Theta is the inverse cosine of 16 divided by square root 14 times square root 21. We can do some simplification with those square roots, but let's not bother doing that. Is the angle acute or obtuse? Well, all we have to do there is the sign, because V dot W is positive here, theta is acute. If this was a negative dot product, the angle here would be obtuse. Okay, problem number 27. Decompose U into U parallel plus U perp with respect to the vector V is 1, 0, 1. So for this one, yeah, U is 1, 5, 2. V is 1, 0, 1. So to find the component of U parallel to V, the projection of U on V, this is going to be, what do we do here? The formula is U dot V divided by V dot V, all of that times V. Okay, so we need to do V dot V is 1 times 1 plus 0 times 0 plus 1 times 1 is 2. U dot V, 1 times 1 plus 5 times 0 plus 2 times 1 is 3. So the projection of U onto V is going to be U dot V is 3 over V dot V is 2, 3 halves times V. So it's 3 halves times 1, 0, 1. And so this is 3 halves, 0, and 3 halves. So this is our U parallel to V. To find the U perp, the other part of this decomposition, what do we do? We're going to just have this be U minus the projection we just found. So all we do is 1, 5, 2 minus 3 halves, 0, 3 halves. And so this is 1 minus 3 halves is negative 1 half. 5 minus 0 is 5. 2 minus 3 halves is 1 half. So our decomposition, our final answer to problem number 27 is U is equal to 3 halves, 0, and 3 halves, plus negative 1 half, 5, and 1 half. So let me make the following. There's basically by saying this is our final answer, I'm making 3 assertions here. Number 1 is that this plus this gives us u. So check for yourself. This plus this, 3 halves minus 1 half is 1, 0 plus 5 is 5, 3 halves plus 1 half is 2. Guess you don't have to check for yourself because I just checked that for you. The second claim that we're making is that this is parallel to v. And yes, 3 halves, 0, 3 halves is a 3 halves times v. So that checks. The third claim that we're making here is that this vector, negative 1 half, 5, 1 halves, needs to be orthogonal to 1, 0, 1. And so let's just check that claim here. Negative 1 half, 5, 1 halves. This needs to be, this needs to be something orthogonal to v. And so if we do this calculation, negative 1 half times 1 is negative 1 half. 5 plus 5 times 0 plus 1 half times 1. And sure enough, we get 0. So yes, this checks out. This checks out, and this vector here is in fact orthogonal to v. And so when you're doing this kind of calculation, I recommend to do this check at the end to make sure that everything checks out and you didn't botch up any calculations. Okay, one more problem in the set. Find a vector that's perpendicular to both 1, 0, 4 and 2, 3, 4. And I left this one deliberately ambiguous. There should be lots of possible answers here. So 2, 3, and 4. And so just as an example here, U is U1, U2, U3. If we set U1 to be, let's set U2 to be 0 and just see what happens. This would tell us that we would need 1 times U1 plus 4 times U3 to be equal to 0, because this is saying that v dot u is equal to 0. And we also would need 2u1 plus 3 times 0 plus 4 times u3. We would need this to equal 0. And let's see, what do we end up with here? What do we end up with if we subtract the first equation from the second equation? We would get u1 is equal to 0. Okay, and then plugging that in, actually, 4u3 is equal to 0. And so we just end up with the 0 vector, which maybe we should have just gone with in the first place, because something we know about the 0 vector is the 0 vector is orthogonal to every single vector. So if, a slightly silly answer we could have given here, I shouldn't say silly, an insightful answer, find a vector that's perpendicular to both v and w. Even though I don't tell you what v and w is, what v and w are, you can just say the 0 vector works. Maybe let me try to find a non-zero vector that is orthogonal to both v and w. And instead we say that u is equal to u1 comma 1 comma 4. Oops, sorry, u1 comma 1 comma u3. So v dot u is still equal to u1 plus 4u3 is equal to 0, but now we have that 2u1 plus 1 times 3 plus 4u3 is equal to 0. So now, if we subtract the first equation from the second equation, we'll get u1 plus 3 is equal to 0, which shows that u1 is equal to negative 3. And then if we plop that into, say, the first equation, negative 3 plus 4u3 is equal to 0. 4u3 is equal to 3. u3 is equal to 3 over 4. So a non-zero vector that is orthogonal to both v and w is going to be u1 is negative 3, comma 1, comma 3 over 4. There are many, many, many possible correct answers here. If you did it in a different way, you very well could have gotten to a different answer. That just check for yourself that your vector dotted with v and your vector dotted with w give you 0 in both of them. When I set like this to be 0 or this is equal to 1 earlier, that was just an arbitrary choice. There's a couple of degrees of there's at least one degree of freedom that we have here. So I just decided to set that equal to 1 and see how everything chases out. If you decide to set u1 equals 1, that would have been completely fine. You would have gotten to a different vector. Your answer would also be correct if you did everything correctly.